Hello everyone and welcome to my channel. Hope all are doing well. So for today my topic is ion exchanges and theory of ion exchange. In ion exchange chromatography, retention is based on the attraction between the solute ions and charged sites bound to stationary phase. Columns used for an ion exchange are characterized by the presence of charged groups covalently attached to the stationary phase. Ion exchanges contain bound positive groups, whereas cation exchange contain bound negative groups. The process by which a mixture of similar charge ions can be separated by using an ion exchange resin. Ion exchange resin exchanges ions according to their relative affinities. There is a reverse exchange of similar charged ions. Mostly similar charged ions like cations or anions can be separated by this technique. Here, negatively charged analyte, that is anion, is attracted to positive surface, whereas positively charged analyte, that which is cation, is attracted to negative surface. Principle: reversible exchange of ions between the ions present in the solution and those present in the ion exchange resin. There are two types of ion exchange: cation exchange and anion exchange. Cation exchange: the cation retained by the solid matrix of ion exchange resin can be eluted by using buffers of different strength, and hence the separation of cations can be effected. Anion exchange: separation of anions using anion exchange resin. The anion retained by the solid matrix of ion exchange resin can be eluted by using buffers of different strength. It is shown diagrammatically. Anion exchange. Now, the selectivity of ion exchange basically depends on the three major factors: higher charge, decreased hydrated radius, increased polarizability. This is the basic instrumentation. Ion exchanges are of three main classes: resins, gels, and inorganic exchanges. Ion exchange resins are used for the separation of small molecules. Ion exchanges gels are used for the separation of large molecules like proteins, nucleic acid. Separation involving harsh chemical conditions like high temperature, high radiation, strongly basic solution, or powerful oxidizing agents employ inorganic ion exchanges. Now, ion exchange resins are classified in majorly three types: strongly acidic cation exchanger, weakly acidic cation exchanger, strongly basic anion exchanger. Now, in strongly acidic cation exchanger, sulfonic acid groups attach to styrene and divinyl benzene copolymer. Weakly acidic cation exchanger, carboxylic acid groups attach to aryl and divinyl benzene copolymer. Strongly basic anion exchanger, quaternary ammonium groups attach to styrene and divinyl benzene copolymer. Effects of pH on ion exchange. Varying pH is usually a preferred way to change selectivity in ion exchange separation. An increase in the pH leads to greater sample ionization and retention of ion exchange HPLC. Example: antibiotics containing COOH group. Decrease in pH favors retention of bases by cation exchange HPLC. Only the ionized form of acid or base will be retained significantly. Effects of organic solvents. Addiction of an organic solvent to mobile phase results in decreased retention, such as in the case of reversed phase HPLC. Solvents such as methanol or acetonitrile are also often used in ion exchange to create changes in selectivity. Effects of buffer. In ion exchange, sometimes a particular salt is selected to provide stronger or weaker retention. A strong displacer reduces sample retention more than the same concentration of weak displacer. In general, more highly charged displacer are stronger. Now here, for example, a mixture of sodium, hydrogen and potassium can be separated by using cation exchange resin. A mixture of chlorine, bromide and iodide can be separated using basic anion exchange resin. For the procedure, mixture of chloride, bromide and iodide is passed through basic anion exchanger using 0.5 molar sodium nitrate as elute. Chloride will first elute, raise the concentration of sodium nitrite. Bromide will elute, raise the concentration of sodium nitrite further. Iodide ion will elute. So the advantages and disadvantages of ion exchangers are: advantages: detectability, useful for the detection of many inorganic salts and also for the detection of organic ions with poor UV absorbability like alkyl amines or sulfonates. Preparative separation, usually preferred because of availability of volatile buffers. Volatile buffers make the removal of mobile phase easier. Useful to resolve more complex samples, that is, in the case of multi-step separation. Useful for separation of mixture of biological organic origin and organic salt and some organometallics. Disadvantages: column efficiency is less. It is difficult to achieve control over selectivity and resolution. Stability and reproducibility of the column become questionable after repeated use. That's all. Thank you for watching the video till the end.